Okay, so we're excited to have you here. I want to welcome you to Flatiron School's Cybersecurity Tips for Software Engineers. My name's Catherine Sommerfeld. I'm the Director of Marketing Campaigns and Events here at Flatiron School, and part of my team's job is hosting free introductory workshops like this one to give you the opportunity to meet some of our instructors and get a better feel of the Flatiron School experience. So as a quick reminder, we'll be using the chat as our main source of communication, so please make sure that you set that little blue button to everyone rather than host and panelists so that we can all chat together. Without further ado, I'd like to introduce our guests today. Alyssa's here representing our admissions team. CJ is here representing our software engineering team, and John is here representing our cybersecurity team. So I'm going to let you guys go ahead and take it away.
Okay, thank you for that, Catherine. So first and foremost, again, I introduce myself. I'm CJ. I'm one of the enterprise software engineer instructors here at Flatiron, and today it's my pleasure to present on the secured software engineer. So we're really going to be deep diving, discussing how cybersecurity and software development intersect. We're also going to talk about developer roles in this intersection, how important it is to keep our software secure, and also just the importance of security at every stage of the software development lifecycle. Okay, so let me go ahead and to slide. Okay. So let's start with the foundation of what the software development lifecycle actually is. So the SDLC, as you might see is what the acronym, is a well-established framework for organizing application development work from inception to decommission. And in the earliest software development lifecycle systems, organizations waited until the testing stage to perform security-related activities. And in many cases, insecure code went out of the door because of time constraints. So just because of security and really because of time, security was put to the back burner of things. Just because a lot of times companies didn't feel like they could account for that. Maybe it was time or costly, things of that sorts. But as we know, in today's age, security is very, very important. It's essentially a must. So the later a bug is found in the software development lifecycle, the more expensive it is to fix it. When a bug is found late in the cycle, developers must drop the work they've been doing and go back to revisit the code they have written maybe weeks or months ago. What can make things worse is when a bug is found in production. The code gets sent all the way back to the beginning of the software development lifecycle. At this point, the domino effect can kick in, and fixing bugs winds up bumping up other code changes that you've done before. So not only is this bug going to cost more to fix as it moves through a second round of the SDLC, but a different code change could be delayed, which adds costs as well. And so we're going to do a quick pause and look at this diagram that we have below. So right here are the different phases of our software development lifecycle. These phases are subject to change depending on where you work and the methodology that you're using for your lifecycle. And these different blue circles that we have in our timeline represent potential security risks at each stage. And again, in the previous way that we saw the software development lifecycle, these blue security risks were kind of left unaccounted for, unaddressed. A lot of times they're just put to the back and kind of say, okay, whatever happens, happens. And that would lead to a lot of faulty software and a lot of later costs that would be added towards the end, when having to go back and redo your work. And that's really one thing that's important to note with establishing security. So if I were to, let's say, encounter a security risk at phase 4, and let's say, okay, I've already completed phase 1, phase 2, and phase 3. Now I have to go all the way back to phase 1 and redo everything from start, because that means phase 2 is dependent on phase 1, phase 3 is dependent on phase 2, et cetera, et cetera. So that's why it's important at each phase that you're doing to incorporate security and incorporate rather security best practices to ensure that your application or your software is going to be fully secure by the time of release. So let's talk about the SSDLC. So we know what the SDLC is. And again, it's essentially the phases or steps to carry out software development. And sometimes these phases can be boggled down as planning, design, development, testing, and deployment. But the SSDLC is secured software development lifecycle. So we're adding security into each phase of our lifecycle. So for us to actually make secure software, we must take the necessary steps for implementing security into each of these phases, as I mentioned. And this starts with a security culture and or mindset. It's really about creating a culture and mindset that incorporates all of the stakeholders of the software development and delivery. It's not just about delegating into the cyber teams or security teams, or rather just those in charge of security operations. It's realized by a security mindset across an entire organization that all teams are working together for a desired level of security for their software. Now, obviously, this requires a ton of collaboration and a lot of implementation of processes to enact this mindset. But the root is essentially just having that mindset and culture to start with in your entire organization. Next, we have shift left. And essentially, we don't want to shift left, we want to start left. And shift left is a saying in in the programming industry. It's the practice of moving quality, testing, and performance evaluation earlier in the development process, often before any code is written. It's not just about integrating security into our existing development phases, but even before these phases even begin in our planning phase, design, et cetera, et cetera. Lastly, what we want to do is look at this diagram before we move on to the next points. So in our traditional quality model, right, we see in the purple, we kind of push security to the end of our development lifecycle. And that means in our planning, development, and testing, there could be potential security risks with us maybe choosing a faulty third-party library, with us choosing the wrong methodology, with us not really doing any method testing or really any a lot of different methods that we're going to learn later on as I move on my slides that we can see we can do in these earlier phases. With the shift left model, or rather with the start left model, we're integrating these security protocols and these security best practices. So at the end, when we actually release things, we know we have a fully secured application. And so let's jump into the next point. Make room for security and planning. We essentially want to build security into our initiative. This starts early in the planning phase with defining what security means to your organization, then moving into the design phase securely by allocating time to do secure architecture design. Essentially designing our software in a way that security is top priority. And let's look at some examples for how we can actually do this. Before we're going to set up this example with a scenario. And then when the scenario, we're going to talk about how we could have maybe do some things a little bit better. So this is a scenario I'm sure we've all encountered or we know someone has encountered before. And let's say we have an end user who ends up clicking a malicious email link. That happens almost every day, probably thousands of times every day across the world. So how did this happen? In security, we can have the best security technologies, the best tools, environments, etc. However, if a developer isn't aware of best security practices and initiatives, a small mistake, like maybe using a third-party tool, can compromise the entire security protocol of that organization. So let's see what roles do a developer play in establishing a secure software development lifecycle. It's impossible to produce secure software and have a secure software development lifecycle without developers who are ensuring what they're developing is meeting the goals and objectives of the secured lifecycle. Objectives and goals need to be clear from the start, and this starts with always assessing risk. Where are we getting our third-party components from? What type of testing will be involved? How secure is our source control? These are all questions we need to ask ourselves when assessing risk. Devs also need to be educated and aware on secure development processes. Also, knowing how to utilize tools and grow in security, basically, learning as we go. We just talked a little bit about secure dev processes and incorporating security at each stage of the SDLC, but what are some actual examples of this, as I mentioned in our last slide? So early in our secure software development lifecycle, we can conduct an architecture risk analysis. This includes things like threat modeling, analyzing your security risks by thinking like a hacker. Really, threat modeling identifies the type of threat agents that can cause harm. It adopts the perspective of a malicious hacker to see how much damage they can actually do. Also, we have a design review. You can find out if your application's architecture and infrastructure align with business practices. And I have this cool link right here where you can actually, I will send it in the chat and I'll make it available afterward as well, that you can actually perform this risk analysis and this threat modeling. So a lot of times, with an organization or, as freelance developers, you might not be able to afford something like this. Again, this is something you can carry out with a third party, trusted company as well. So Synopsys is actually a very trusted company. But again, this is something that's maybe used by larger scale companies, like larger sharks, as you might say. So for us freelance developers, we can still perform this check as well. There's actually few documents, such as this, where you can perform a risk analysis yourself. It's a bit longer and a bit more of a learning curve, but you'll actually, see through and through how you can, read through a document and do a step-by-step check of your own software to see if it's actually meeting those desired security protocols. And again, I will make both of these links available for us after today's presentation. So, and along with any other links that I will be showing you all. Okay, so let's talk next about the secure development methodology. So there are numerous methodologies for the software development lifecycle, including waterfall, iterative, agile, etc. It's important to understand the pros and cons of these methodologies and how a particular methodology could help or hinder you carry out the security demands for your software. As I mentioned earlier, it's about making security priority at every step along the way in the SDLC. In the development phase, it can be doing static and software composition analysis, basically an automated process that identifies an open source software in a code base. And in testing, it can be doing pen testing, something such as, deciding when to set up environments as well. Or, like pen testing would be, pretending that you're a hacker and trying to penetrate your system's, walls to see, how effective and how strong they actually are. I actually have this other link that I would like to share with us on the Microsoft software development best practice. And this is a methodology that's offered by Microsoft and used widely. It's very, very used amongst, all companies. It's considered to be, a best practice for a lot of companies to use. And so with your organization or even yourself as a freelance developer, you can follow their protocols and some of their different trainings that they offer. They even have these practices outlined at the bottom of this link that I sent over, just showing you the different steps that should and must be taken to ensure that your software is secure. So just some takeaways and some best practices before I hand things over to John. So it's always important to keep software up to date and patched. Every piece of software has issues at times, as we all know. There's no really way to avoid that, but this is one of the most common ways that hackers take action on software users. This is why regular patching and staying up to date on software is an important step in ensuring software security. Least privilege. This is one of my favorite best practices. Least privilege is the concept of giving software users minimal access to get programs in order to get their jobs done. In other words, don't give them, access to features, access to rights or controls that they don't need to use. Third, we have consider automation for software security tasks. Large companies or enterprises can't keep track of the wide range of tasks that they need to perform on a regular basis manually. This is where automation comes into play. Think about it. If hackers are using it, you definitely should be using it too. And they are definitely using automation tasks, on their end, which is, the side we don't want to be on. Lastly, we have education, education, education. Software security risks just won't go away at the press of a button. Educating employees is an important part of guaranteeing software security and minimizing software security vulnerabilities. And with that being said, I want to pass things over to my buddy John, and he can share some best practices on cyber side as well.
Super cool. Thanks, CJ. Yeah, let me go ahead, share my screen. And then just let me know if you guys can see that. Am I all good right here?
Yep.
Thank you, CJ. Yeah. So yeah, once again, thank you, CJ. And just bouncing off of everything that CJ is saying, 100% true. All of the concepts that CJ talked about are also things that we use in cyber. So to go into a little bit more of a deep dive, a little bit more of a topic on like how cyber works in development or with software, right? I'm going to go over a little bit of the OWASP secure coding practices, as well as just kind of demo what these vulnerabilities look like if we don't really follow through with the best practices, that we learn and that we continue to learn and try and implement. And sometimes I'm going to actually kind of show this off too. What we think is just enough security usually won't be just enough, right? So let me go ahead. Look here. All right, so the first thing I do want to introduce to everyone is the OWASP framework. And OWASP basically stands for Open Worldwide Application Security Project. It's a really neat resource if anyone is actually interested in continuing to learn about security for web applications, things like API. And if you guys have been doing any research, been looking into cyber software or like any kind of dev, you might have came across something called the OWASP Top 10. And that is essentially just a really great resource to build awareness on the top 10 most critical web vulnerabilities and API vulnerabilities that are out there right now. So it's updated pretty frequently, and it's a really great way to see what's trending in the world of actual like vulnerability and what we need to be anticipating and looking towards as technologies evolve and the future's coming. So this is just a really also developed by OWASP, secure coding practices, just a quick reference guide. So I know for me as a cybersecurity engineer, offensive security engineer, if a website follows all these like all these categories, right, of different security practices for secure coding, I know that the website will probably be pretty solid in its structure, for its like use and everything. So I know that input validation, as long as we're validating input that a user is putting in, we should be solid with everything. Output encoding, authentication, and password management, all these are things that when we look at websites on cyber side, we want to make sure that they follow. And just a little bit of background, I know that if a website fails in any one of these categories, it's probably going to be vulnerable to a lot more things. So when we try and do exploitive work inside of cyber, one vulnerability will usually lead to another. And we do have, once again, like a domino or a snowballing effect. We usually use small vulnerabilities, small exploits, and build on top of them to gain privileges into different types of larger and larger, more complex and effective like tools to gain information, gain access and everything. And obviously why we do this is we want to make sure that the people that shouldn't be doing this don't actually have access to do this. So we want to make sure that we know exactly what's going on. I know someone somewhere at some time said, knowing is half the battle. So being aware of these best security practices, being aware of secure coding practices, and just different roles within the organization is a good way to make sure that we build the best applications that we possibly can. And I know in just recent times, the US Department of Defense and the US Cyber Command have been really pushing this concept of defending forward. And I really like this, and it's something that I've really been wanting to share. So we want to take on a more proactive approach to defending our systems, defending our networks, web applications, websites, servers, basically anything that we host that's connected to the internet. We want to be proactive in making sure that it's secure. A lot of times we say it's not a matter of if, but when. But if we defend forward, if we take a proactive approach, practice a lot more secure coding, and practice a lot more of what the hackers will do and what a lot more threat actors and bad actors will do, we can learn from them to correct our mistakes. So a lot of times, this is a concept that I do want to, keep pushing and move forward with us a little bit. And I do want to show just right now a really quick demo on what happens when we don't actually follow through with some best practices. And even when we think we're good enough with it, ways that we can bypass it, and then ways we can also correct those things. I'm going to go ahead, switch my screen one more time. And right here, I have a virtual box up with Kali Linux. For us in cyber, it's a tool, it's a virtual machine that we really love using. And right here on my left, you'll see that I have something that looks like a little bit of an e-commerce shop. And that's basically where we're going to find a lot of these vulnerabilities, is a lot of insecure practices being used for people that are just starting up and really don't know how in-depth security can be. So right now I see that, really simple e-commerce shop. On my right over here is one of my favorite tools. It's called Burp Suite. It's basically a tool that we use to intercept and modify requests. So Burp Suite is a proxy program that we will use to analyze requests that are coming from this web server right here. So I'm going to go ahead, just do a really quick demo and just show a really simple vulnerability that shouldn't be exploitable, but in this case it is. I'm going to go ahead, turn intercept on, and I want to go ahead, click on a product, and then we can see that we've intercepted a request. So every time that we visit the internet and every time that we try to load a web page or something, all these requests and everything go in the background. And this is actually kind of what it looks like, right? So a lot of information here, a lot of things that we don't necessarily need to know, but the more we know about it, the better it is, right? So I'm going to go ahead, forward it until I see something that I know as a security engineer is vulnerable. So I see here an image URL that's requesting a file name for an image. In this case, it's going to be 64, and I can actually, I know that this is probably pretty small, so let me go ahead, make this just a little bit bigger if I can. Works slightly, but that's all right. So anyway, I can go ahead and modify these requests and basically simulate what an attacker would do to try to gain privileges to different parts of the system that this website's probably using. So I'm going to go ahead, send this over to the repeater, and I can go ahead, turn intercept off here, and I have this request in the repeater now. And what I basically want to try to do, this looks like to me it's vulnerable to a directory traversal or a path traversal, as in this lab it says. So I'm going to go ahead, modify this request, and test it for path traversal. And path traversal is basically a vulnerability where we're able to go up and outside of a file. So if we have a structure of files, we can try to travel outside of those files into directories or folders that we shouldn't have access to. So I'm going to go ahead, test it out. I'm going to go ahead, forward that request. And I can see that, hey, it's a 400 error on this HTTP. It doesn't exist here, but that doesn't deter me. I want to find let's actually try to define specific files. This would be an absolute file or absolute path directory traversal. ECT. We're going to try it one more time. I don't see that it doesn't work, but that doesn't mean that it's not there. I'm going to do it one more time. Let's see if I did that right. // And I think I know it's here. Ah, there we go. Okay. So I'm just going to keep playing around, modifying this request until I get something that I know is vulnerable. It doesn't look like I'm getting the request that I want. Very unfortunate. Well, I don't want to spend too much time here with this, but this should have been vulnerable to a directory path traversal, and I can actually test it out on this other one. Let's see really quick. Oh, and you know what? This is on my bed too. So for me, a super simple typo caused me to actually 100% miss what I was looking for, right? But it doesn't deter me, right? So right here, I was able to pull the directory etc password. And this contains a lot of user information for that system. So with this, I would be able to potentially escalate this into a larger like privilege escalation attack. And just because we think that something is secure, just because we think that there is no vulnerability there actually is. We just have to be vigilant, right? So how do we prevent something like this from happening? And for that, I would actually say we have to do a lot of input validation, and we have to sanitize a lot of the data that we're trying to send into a server. So those are just two ways in particular that we could prevent something like this from happening, and also just being aware that different types of vulnerabilities, in this case, directory traversal, actually exists. So I'm going to go ahead, stop my screen share right there. And from me on my side, that's basically all I have. I just want to demo that really quickly for you guys. Is there anyone that has any questions or anything while we are still here in this chat?
All quiet today. All right. Okay, then I will jump back in here to say thank you to everybody who zoomed in to join us today. If you have any further questions about Flatiron School, Alyssa just dropped the link to schedule a chat. Nope, she just dropped the link with the cybersecurity information, and there's the admissions email address. As a reminder, you will receive a copy of today's presentation within 3 business days after our event. If you'd like to see any of our previous events, you can head over to our YouTube channel and subscribe. Again, I want to say thank you and have a great day.